Hey guys, this is the second video where I'm going to show you guys how to do the average velocity, the average speed, the different graphs, and so forth. Anyways, we figured out the x-intercept already, and we needed that because we need to find the areas of each box to figure out the distance. So we figured out already that this crossed the x-intercept at 4 2/3. So we're going to make this box right here, which has a height of 4, because it goes from 0 meters to 4 meters per second, and a width of 4 2/3. All right. So if we found the if we found the area of this box, we do 4 times 4 2/3, and we would get 16 8/3, which simplifies to 18 2/3. But that's the area of the whole thing, so now we need to figure out the area of this underneath the line. So we would need to divide that in half, and we would simply get area of 9 1/3. So that's the distance traveled in the first interval. So now we need to repeat those steps and for this second interval. So we got to find the area of this box, which we see the height is 2, and we figured out the width to be 2 1/3, and this is actually going to be really easy to do. When we multiply those two, we get 4 2/3, then we need to divide it in half. So the whole area would be 4 2/3, which we will need to divide in half to get the area of this triangle up to 0, which once again is just 2 1/3. So 2 1/3 is how far we go in interval 2. So you guys needed to find like the total distance traveled. Well, we would just do for total distance, we're gonna have 9 1/3 plus 2 1/3, which will give us 11 2/3. Then our total displacement which is equal to, we had a positive 9 1/3 because we were moving forward in the first interval, but then we have to subtract the 2 1/3, and we would get 7, a positive 7. So we need to use the total distance to find our average speed. So to do average speed, we need to do 11 2/3 divided by 7 seconds. Okay, and what we end up getting, let's see, that's 1, you factor out 4 2/3, 4 2/3 is 14/3 divided by 21/3. No, it's just 2/3. So it's 1.6 repeating it, and that's meters per second is our average speed. Our average velocity is going to be really easy because it's simply 7 meters per second. It's going to be 7. Our total displacement was 7 meters divided by 7 seconds, which just gives us 1 meter per second forwards because it was a positive 7. Anyways, those are our total distances, our total displacements, our average speed, and our average velocity. You also, though, needed to do graphs for position versus time. So let me see if I can just, yeah, I can, sweet. Make that smaller, bring that over there. Now to do these graphs, okay, I'm just going to make it really rough, I'm sorry. We have our first point at 0 0. I know that that first interval went to 4.6 4.6, and we went to a height of 9.3, repeating. Anyways, our first interval was going off fast from the beginning, and then it slowed down and reached a speed of 0 right here at 9 1/3 and 4 2/3. For 7 seconds, we need to go, if this is our, let's do our distance. We needed to go an additional 2 1/3 from there, so we're going to go up to 11.6 at 7 seconds, but it starts off slow and gets up to that point of 7 and 11.6. So your graph should have looked like that. Anyways, if it was just your position, so I'll do position in blue, would have had that same first line because it went forwards, but then instead of going up by another 2 1/3, it would have went down 2 1/3 to a point right here of 7 and 7. That's what your position versus time graph would have looked like, is the blue line, and your distance versus time is the red line. Now for the acceleration, it's going to get kind of funky. For the acceleration, this was tricky because you need to think which one is positive and which is negative. The acceleration, one of them is slowing down, which is actually meaning it's losing a certain amount of speed per second, and the other one is speeding up, gaining a certain number of meters per second. And what's happening here is in that first interval, you were changing, and this is going to be meters per second squared, you were changing by 6 meters per second per 7 seconds. So 6/7 of a meter per second squared. So if I had negative 6/7 meters per second squared and a positive 6/7 per meter per second squared, and then I have a time of 4.6 seconds right here, what you would have seen is that in that first interval, my acceleration was negative 6/7 meters per second squared, okay, and that would have went for the first 4.6 seconds. Then it switched to speeding up, so it was gaining 6/7 meters per second squared, and I just realized I drew that way too far because this is only supposed to go to about 7, which means I would need to erase to right there. Anyways, that's how you were supposed to do the acceleration versus time. And I hope that was helpful.